In this chapter, we will be studying trigonometry. In this lesson, we're going to look at triangle labeling and the Pythagorean Theorem. Okay, hi everybody. So today we're going to start our chapter on trigonometry, and we're going to start by talking about triangle labeling and the Pythagorean Theorem. Okay, the title of the video here. Because what we want to do is, before we get into trigonometry, we want to make sure that when we start to talk about some of the ideas, we start labeling triangles and whatnot, because trigonometry is the study of triangles, we want to make sure that you understand exactly what it is that we're saying here. And there are three different ways that we can label triangles typically. Okay, we've got the Pythagorean labeling, we've got relative labeling, and vertex labeling. So now, actually I'm going to just try to stop it from doing that little scan there. There we go. So we're going to go through each one. We're going to start off with the Pythagorean labeling. Okay, and what this is here is, in any right angle triangle, there's always one side that's longer than the other two, and that side is always opposite the right angle. Okay, so notice that to get that right angle, we need two sides. We need two line segments there to make that right angle. We call those two legs. And the one that's on the other side of the triangle, the one that's not being used to build that right angle, is called the hypotenuse. Okay, it's always across from the 90 degrees. It's labeled the hypotenuse. The other two are legs. Okay, and so that is one way that we can label a triangle here. Okay, we talk about the legs as separate from the hypotenuse. Okay, the next type of labeling we're going to look at here is called relative labeling. And this one's really important when you start looking at trigonometry. Okay, in relative labeling, we always start with a reference angle. Always start with the reference angle. This is what determines how we're going to label the different parts of the triangle here. Okay, so, and you can identify what that reference angle is, because that would be a good question. Like, what is the reference angle? What is it that I'm using here that's so important? Well, it's either going to be the angle that you're given or the angle that you're finding. Okay, but there's going to be an angle in any question that you're looking at. There's going to be an angle that's important. That is what everything is kind of based on, hinges on. So as soon as you've identified that angle, then there are two words that we use to label the sides. There's the opposite side and the adjacent side. That is always, like it says here, relative to the reference angle. The hypotenuse, just like it is in the Pythagorean labeling, is always the side that's opposite the right angle. Okay, it's always the one that's not being used to make the right angle. So what relative labeling really is, it's a way for us to differentiate the two legs of the right angle triangle. So let's go down here. So for example, if we determine that this angle up here is the reference angle, it's the one that's most important. It's either the one that I've been given or the one I'm asking for, then the side down here is the opposite side to that angle. Okay, so we would just label this the opposite side. This one right here is one of the sides being used to make that angle, the reference angle. Okay, we've got this side right here, and this one right here is the hypotenuse. Can't change that. That's the one that's opposite the right angle. So this angle is built from the hypotenuse and a special leg, and we call that leg the adjacent to the angle. Now, if our angle had been the other one, if it had been down here, our reference angle, and there probably should have been an A there as well. Probably is there, it's just in the computer, it's probably just underneath the diagram there. So here's our reference angle. In this case here, this side over here is the opposite side, and this side right here is the adjacent side, again, because it's being used to actually make that angle together with the hypotenuse. Okay, so that's another way that we can label the triangle. Okay, now the last type of labeling is what we're going to call vertex labeling. So with vertex labeling, we use capital letters to represent the vertices of the triangle, and we use lowercase letters for, of each vertex to represent the side opposite that vertex. Now, that's a bunch of blah, blah, blah. It probably makes way more sense just to look at an example here. So here are our the three vertices of our right triangle here. And notice that we're using capital letters to label those vertices. That's a really common thing to do. Okay, so to label the sides, what we do is we take angle A here, and we draw an arrow to the other side of the triangle, this is little a, lowercase a. Is going to be this side right here. It's on the other side of the triangle. Little c is going to be the side that's opposite capital C. So in this case, because capital C is the right angle, little c here is going to be the label that we give to the hypotenuse. And b is down here. Okay, so b is the label of this angle right here. And so over here, it's the opposite side is going to be the lowercase b. Now, one other thing that I want to show you just before we leave this, okay, because now that we've started to label the vertices here, another way of mentioning the angle here starts to pop up. Let's say that I wanted to specifically refer to angle B. Okay, I could write simply angle B, or I might write it as angle ABC or angle CBA. Now, when I write angle ABC, what I mean is starting from vertex A, I go over to B and then over to C. And there's my angle here, where the middle letter here becomes the vertex of the angle. Now, I'm only bringing this up because I've worked with students and I've watched people get confused by this. If we don't talk about it, sometimes when I say find angle ABC, I'll have students find all three angles here because they're not sure what I'm referring to. So just want to make sure that the notation it makes sense here. When we say angle ABC, the B here, the middle letter, that's the vertex. So if I was referring to angle A, okay, I might say in this case that that's angle, let's say CAB. Or I can come at it the other way around and come and call it angle BAC. Okay? But again, it's that middle letter there that is referring to the vertex. Now, you might just refer to it by its vertex label, and that's fine until you get more complicated drawings where we maybe have, multiple triangles being drawn in a single question here. So it's just another way of labeling. Okay. Now, it doesn't really matter what course you're in. Anytime we start to talk about trigonometry, we got to talk about the Pythagorean Theorem. That's kind of one of our starting points right here. So the Pythagorean Theorem is a relationship between the lengths of the sides of a right-angled triangle. And the ancient Greeks discovered this a very, very long time ago. So when you label the sides of a triangle, particularly with that Pythagorean method that we made here, this length right here is a leg. This length right here down here is a leg. Sorry. This is a leg, and we're interested in the lengths here. And this is our hypotenuse. Now, it turns out, okay, if you take the length of that leg and square it, which is basically, you multiply it by itself, and what you're doing is you're actually creating the area of that corresponding square. Okay, because if we use that length there again, we get a square that's got that area to it. This one right here, if you take this length, draw it down here to create the square, that's the area there is just multiplying that by itself. It turns out when you add those two areas together, you get the area of this square, where that's the hypotenuse and the hypotenuse right there, the length of the hypotenuse there. Okay? So, the relationship that we get here, and I'm sure you're already well aware of this, okay, is that if you've got that 90 degrees in there, then the sum of the two legs, the sum of the squares of the two legs is equal to the square of the hypotenuse. Okay, so when we say area here, what we're meaning here is you're creating a square out of that and finding the area. So in other words, the hypotenuse squared is equal to the leg squared plus the leg squared. Now, frequently when I say the Pythagorean theorem, people say a squared plus b squared equals c squared. Now, that's true if your triangle is labeled like this. If we put if we got the A, B, C, and so this becomes little a, this becomes little b, and this is your little c, then yeah, that's true. But if I label a triangle like this, if I just change things a little bit, and let's say this is A, this is B, this is C, then I have to be able to adapt to that because here's how my labeling changes. Remember, if I use that vertex labeling, if this is the angle A, then the side opposite that is going to be little a. If here's B, the side opposite is little b. If this is C, the side opposite is little c. So then the Pythagorean theorem becomes b squared plus c squared equals a squared. Okay? So you just need to be able to adapt to the labeling if the labeling changes. Okay? Normally we would label it like this. We would put the C on the right angle, but that doesn't have to be the way we do it. Just want you to be aware that could happen, because I've seen all sorts of students that will still take this and still make it a squared plus b squared equals c squared, because that's kind of their default way they memorize that, even though it doesn't match up with the new triangle that they're working with. Okay, so turns out we can use the Pythagorean theorem for a few different things. We can use it to test to see if an angle is 90 degrees, okay, or whether the triangle that we're actually looking at is acute or obtuse. We can find the measure of the hypotenuse using the given legs, which is normally how you think to use the Pythagorean theorem. Most people, that's kind of their default thinking on that one. Or you can use it to find one of the legs if you're given the hypotenuse. Now, although most people do practice this, oftentimes people approach this last one wrong here. They approach it as if it's this second one where you're finding the hypotenuse. You just got to be careful that you know what it is that the question's asking. So let's just take a look at the first question here. Since we're going to test an angle, so we're going to prove whether or not these triangles are right angle triangles. If they are not right angles, then classify them as acute or obtuse. Now, you sort of have to trust the diagram is giving you an idea of what things look like, but not perfect. Okay, so please, don't pull out your rulers and start measuring these things and figure out if they are actually in proportion or whatever, because they're typically not. So let's take a quick look at this one. And your little solution here, if you take a look at this, it says the longest side in the first triangle is 13 miles, and in the second one it's 15 miles. Now, in a right angle triangle, okay, if it's a right angle triangle, then it has a hypotenuse. If it's not a right angle triangle, it doesn't have a hypotenuse, okay? But if I don't know if it's right angle or not, then the way I would determine that is just I would grab the largest side. So in this triangle right here, I don't know if this is a right angle triangle, but I do know that since this is the largest side, this is where I think the right angle might be. Now, to see if that's actually a right angle triangle, what we're going to do here is I'm going to take that leg and I'm going to square it, and I'm going to take this leg and I'm going to square it, and I'm going to check to see if that does equal what I think is the hypotenuse squared. So 5 squared is going to be 25. 12 squared is 144. And 13 squared is going to be 169. And if I add 25 and 144, I do get 169. And so you know what? That works. When I take the squares of those two sides, add them together, I get 169. That is a right angle triangle. Now over here, I suspect this isn't a right angle triangle, but they might be trying to confuse me with the diagram. This is my largest side, so I'm not sure if this angle here is 90 degrees or not. It doesn't look like 90 degrees to me, but who knows? Okay, it could be just like a stock diagram that they use, and then they've labeled it as they want the question to look. So this could be my hypotenuse. So let's just check out here. If I take 9 and square it and add 10 and square it, does that equal 15 squared? Okay, well, 9 squared is going to be 81. 10 squared is 100. And 15 squared is 225. Okay, so if I add those together, I get 181 is supposed to equal 225. Well, that's not true. Which means that wasn't true, which means that wasn't true. So this is not a right triangle. Now let's take a quick look. Notice that what actually happens here is the actual distance that I'm getting here is substantially smaller than the one that's here. Okay? So it's hard for me to say what kind of triangle this is, okay? But I suspect it's supposed to be an obtuse triangle, because I was expecting this to be, well, let's figure this out. if we take the square root of 181, pull my calculator over here, if I take the square root of 181, see, I'm getting a number that's smaller than 15. So if this was a right angle triangle, the distance here would have been 13. So these have been pulled out a little bit, which means this angle right here is actually slightly bigger than 90 degrees. Okay, so that's got to be obtuse. Now, had the number that I found been bigger than 15, then my math here was expecting a larger side, but I'm getting 15, so it's smaller. So the sides have been rotated in, and that angle would have gotten smaller. So instead of going out, it would have come in. But in this case, it went out. It went out because what I calculated here was smaller than what was actually given. So they moved the sides out. So that angle actually has become bigger than 90 degrees, and it's obtuse. Okay, now let's take a look at another way that we might apply the Pythagorean theorem. Okay, so we're going to be told that this is a right angle triangle, and we're going to solve for the hypotenuse. Okay, so in this case here, take a look at what I've got here. I know the length of this leg. I know the length of this leg. Now I'm looking for the hypotenuse here. So I know that leg squared plus leg squared is equal to the hypotenuse squared. Okay, leg squared plus leg squared equals hypotenuse squared. And I might even say leg 1 squared, leg 2 squared. Okay, you're going to see this happen a lot in mathematics, that if I just needed to kind of differentiate two things, like I'm going to use the word leg for both of these legs of the hypotenuse. But if I drop a little 1 here, I know this is like my first leg, and then this is my second leg. I'm not multiplying by 1 or multiplying by 2. I'm just labeling it. So in this case here, this would be 12.5 squared plus 10 squared. It's going to equal my hypotenuse squared. Okay, now I'm going to go to my calculator. Okay, and I'll find that 12.5 squared is 156.25. I don't need my calculator to tell me that 10 squared is going to be 100. And that's going to equal my hypotenuse squared. I will add those together to get 256.25 is equal to my hypotenuse squared. Now, although most of the time people are really good about this, every once in a while people forget that you have one more step that you got to do in order to get the answer. Remember, this is equal to the hypotenuse squared. So what I have to do is I have to take the square root of both sides to get what the hypotenuse is. So what I really need to do here is take the square root of 256.25. Okay, so again, that's just calculator work. My square root of 256.25. And I'm going to get 16.00. Okay, normally we would round these things to the nearest tenth. That's a pretty common thing to do. So this is going to become 16.0. Our hypotenuse is equal to 16.0, and our units would be centimeters. And that seems pretty good here. This side is 10, this side's 12.5. I know that my hypotenuse is supposed to be a little bit longer than those sides. It is. If I had stopped here, 256 is crazy big compared to those two. Okay, this makes way more sense. So that's the answer clearly that I'm looking for here. Okay, and in this last question we're going to look at here, we're going to use the Pythagorean theorem to solve for a leg. So what we're seeing here is I know what the hypotenuse is this time. I know it's 15. And I know that one of my legs is 5 here. And the other one we're just going to call x right now for the time being. So what I might do here is I might say I've got my leg squared plus my leg squared is equal to the hypotenuse squared. And I might again say leg 1, leg 2. This time I know that leg 1 is 5. And I'm going to put the x right here with this second leg here. Now, in the previous question, there was an x on the hypotenuse, but I just left it as hypotenuse, mostly because, you know, in a case like that, most of the time we default to doing it that way anyway. So, not a big deal. And then here, my hypotenuse is actually going to be 15. So now, 5 squared is going to be 25. x squared. I don't know what x squared is. But 15 squared is going to be 225. Okay. And now I've got that 25 plus something is equal to 225. Well, I don't know what that something is. So what I want to do here, in order to figure this out here, I need to try to get the variable by itself. Now, I've got two terms here being added together. What I really just want is the x by itself here. So I'm going to subtract 25 from both sides of the equation. I've got to make sure I do the same thing to both sides. The two 25s here are going to cancel, so I'm just going to be left with x squared. And 225 minus 25 will just give me 200. Well, I really like that. Really like that, because now I've got the x by itself on one side of the equation. I'm really close to solving this now. Now what I'm going to do here, because this is x squared, last thing I'm going to do is I'm going to take the square root of both sides. Okay, so basically I'm just undoing what that square is doing. And I'm going to take the square root of 200. Okay, just going to do that on my calculator there. And we're going to get 14.1. Okay, 14.1. Now, I want to show you something here. I rounded that. Okay, I rounded that. That decimal kept going here. And I suspect the decimal goes on forever with this one. But I rounded that. So the square root of 200 isn't exactly equal to 14.1. So I'll tell you what, impress your teacher here. Put a little dot above that. Because what that communicates here is, it's approximately 14.1. It's not perfect. I had to round it a little bit, but it's really, really close. Then we put centimeters there. So that's how you do it. And those are really the two, in terms of like algebra and solving for something, these are the two primary ways that we do this. And remember, I could have put this as x squared here, x squared all the way down. And then when I took the square root, just made that equal to x there, just so that we're referring to that properly. But anyway, you're either going to look for the hypotenuse or you're going to look for one of the missing legs. Okay, so I hope that makes sense.